Oh, hello. I'm Lou Cerny, Vice President of Sedlak Supply Chain Consultants, and I'm pleased to welcome you to our fifth annual Lunch and Learn series. This is the second of 5 sessions that we're going to be presenting throughout the year, and it's intended to provide insight into the services that Sedlak and our trusted partners can provide to address your supply chain challenges. The session is intended to be interactive, with the microphones open to be able to address your questions. We do ask, however, that when you are not asking a question, that you mute your mics so that we don't have interference from that. Again, we encourage your questions throughout the session. We'll also have some time at the end to address any additional questions. Now, at this point, I'm pleased to introduce Dave Gailey, who will moderate this session. Dave?
Yeah, thank you, Lou, for the introduction, and welcome everybody. Today we've got hopefully an interesting case study here that we'll go through for the Under Armour project that both Sedlak and FCL partnered together with. We've got Jeff Bonfoy from Regional Vice President from FCL with us, and he'll be getting into some of the detail on the facility design there and some of the lessons learned. We'll start off here with a little background about Sedlak. So we've been in business for 65 years, over 65 years, helping clients with their supply chain initiatives and challenges. We are independent, meaning we do not have any affiliations with the vendor community. Our sole focus is client collaboration and ensuring the best possible outcomes for them to drive the lowest total cost of ownership. So here you'll see our core services, which include supply chain and network strategy, where we assist clients with determining optimal locations and number of nodes in their network. Facility and operations design, which is where basically the focus of the session here today will be. We work with clients to model the business and size the facility optimally, select the best solutions inside the four walls. Operations improvement, which we leverage our expertise to streamline client operations. IT system solutions, where essentially we help our clients to navigate the IT system journey, whether it be selection of WMS, ERP, WES, identifying the key requirements and partner selection and taking that from selection all the way through go live. Project and change management. So we are industrial engineers, most of us by education and experience, and we are project managers. So we generally manage the project on the client's behalf, and then also help them out with leading the change management initiative as we head through process changes and go live and bringing the personnel along the way. And then third-party logistics services. So we work with both third parties on optimizing their network and operations, as well as our clients, working with our clients for third-party partner selection. So thinking about the case study coming up and facility design, there are three potential sizing outcomes: either too small, too large, or the right size. And with a third of the chance of being properly sized, it's important to partner with an experienced team. And the next slide here kind of outlines our four-phased approach for projects like we'll be talking about here shortly to ensure success. So starting with conceptual design, phase one, where and we'll talk a little bit more in detail about this in the next slide, but essentially, that's the upfront effort to pull it all together, looking at the client data, creating a baseline, selecting optimal solutions, and developing a conceptual layout as part of that process. Once that's been established, we segue into phase two, or detailed design and selection, where we develop detailed drawings and essentially create an RFP process or RFP package, where we will go out to bid for each piece of the solution set within the four walls of the DC to to select the partner. We also develop a budget and implementation schedule as part of that process. Then phase 3, which is the next step, which is implementation and integration. So generally speaking, we manage the vendors accordingly throughout the process, drawing review, quality control, ensuring schedules being adhered to, budget tracking. We'll punch list, commission, debug. A big part of the process is always the IT piece, where we're overlaying and ensuring the functionality meets the solutions that are selected. Transition assistance, change management really kicks in at this point. And then phase 4, go live realization, where we would essentially bring the operation up and monitor inbound, outbound volumes and flow, review labor deployment, make sure processes are being followed, ensure that the training that happened up front in phase 3 is a success. And the ultimate goal is to hit the numbers. So thinking about how to start the project, right? So not oftentimes we may come in and a little late in the process, which is sometimes unfortunate. Ideally, what you want to do is you want to start from the inside out and determine the required facility size and clear heights. And essentially, what I mean by that is you want to design the inside of the building in terms of the solution set, the MHE, the automation, everything about the inside of the 4 walls, conference rooms, restrooms, those types of things, to essentially create the footprint of the facility. And then you build the 4 walls and ceiling around that. So to do that, we'll start with it all starts with the data and creating that baseline from the operations perspective, looking at the flows and the volumes through each of the functional areas. We look at inventory levels, handling characteristics. Are we looking at pallets, cases, units? Oftentimes looking at all 3 in a building or a facility in a DC. Once we have that baseline created, we apply the business growth. So we work with the client to basically determine what the growth plan should be. We usually look 3 to 5, sometimes 20 years out, depending on how sophisticated the client is with their planning. We'll identify operational equipment concepts for each of the areas, and then ultimately select the optimal solutions. We don't do it in a vacuum. It's collaborative with the client. Develop the conceptual layout, and then oftentimes we're looking at how much do we want to build up front if it's a new facility, or if we're looking at an existing facility, do we want to have expansion as part of the puzzle, or do we want to build it all at once? So, and then we will build that plan out in terms of how much equipment to buy up front, and then see how the business develops over the first few years to determine if expansion is required or not. It's often how that plays out. So once we get through this process, we've essentially established the necessary DC space. So the go forward and MHE and automation solutions, the building footprint, building column spacing, and clear heights are a handful of things that come out of that process. From a building perspective, so some of the things that need to be considered, working hand in hand with FCL as well, during the Under Armour project. Key design considerations there, obviously the DC floors. So depending on the solutions that are selected and implemented, sometimes there's special consideration in terms of floor flatness and floor levelness that need to be taken into account. An example that would be very, very narrow aisle or VNA, high bay racking. Oftentimes with the order pickers for cases or turret trucks for pallets. And then also, obviously, the point loads for the rack and how heavy are the loads going to be in the rack, and doing those calculations to make sure that the floor can withstand the loads being placed onto it. Electrical, obviously, there's a lot of electrical that goes into a building, no matter the size. There's lighting, there's convenience outlets, HVAC, everything you can think of. But from a an MHE perspective, obviously there's power requirements there that need to be rolled into the overall building power requirements up front to make sure the building has enough to support the entire facility. Fire suppression. So ESFR, the norm nowadays for ceiling heights up to 45 feet. There's some product commodities and hazardous materials that may require in-rack sprinklers, so those things need to be considered and rolled into the building design. And additional structural support. Jeff will touch on this here in a little bit, but one of the examples we ran into with Under Armour is we realized we wanted to support some of the conveyor from the ceiling in order to keep pathways clear from vehicles and personnel. It just wasn't, floor supports just weren't really desirable traditional floor supports for the conveyor in some areas, and Jeff will touch on that, as I mentioned. And then egress. So you need to be mindful of personnel egress pathways in your layout and designed to ensure OSHA and local codes are met. Jeff will touch on that as well, but sometimes that gets overlooked until it's later in the game and you're making changes to either the layout, having to come back and add lift gates and things like that to make sure that code is met. But those are obviously there's so much more that goes into this, but those are the 5 that we've highlighted here. And with that, I will segue to Jeff to walk us through.
Yeah. Thanks, Dave.
FCL and the case study. Yep.
Yeah. Appreciate you guys having me. Really look forward to hopefully introducing some of you to FCL who may not be familiar. And I always enjoy an opportunity to share a little about us and maybe some of our success stories when we were talking about this, and this webinar kind of was culminating together. We talked about a number of topics, and I think there's 3 topics that we'll overall hit on, some of which Dave sort of alluded and touched on. But, I'm hoping that this is a good opportunity to illustrate, a number of common factors. The working relationship that we've developed with Sedlak on complicated projects. 2, the thought process and the ability for us to think on our feet and be able to react to what becomes an ever-changing environment, especially when we talk about these complicated jobs. And 3, I think some of these topics with some of the sizing designs and tariffs and other things are comments and things that we've heard from some folks within this audience. And so we're trying to, capture the overall, everything from very specific in some of the case studies to some very generic topics that kind of are broad strokes. But before we get into it, a little about FCL. We're approaching our 50-year anniversary as a company. We are a general contractor, construction management firm, covering coast to coast, over 250 folks within our group and 10 offices spread throughout the country. I head up our Northeast regional office, which is covering a geographic territory from the Carolinas up through New England. We have over $1 billion annual revenue that's pretty heavily focused, if not core. Our core focus is in this industrial distribution warehouse e-commerce world. We're an employee-owned company, which we're very proud of, and gives us a lot of leverage in how we view projects and the ownership stake that we take in the success of each project. And we have a very heavy focus on customer retention. If we go to the next slide, when we go to these projects and look at why FCL, right? It's embodied within each one of us to how important it is to walk away with an everlasting relationship with everybody that we interact with, such that we can hopefully work together in the future. And when we start talking about some of these even more complicated projects like Under Armour, the institutional knowledge that you learn about the inner workings of the business and what makes the success from a business side, what makes them money, how that interacts with their distribution network is so vital, and information that can really be leveraged when you start working project to project as you go through the future. And so, our experience is what we cherish. Our customer retention is something that we all try and keep as the absolute top mark for our focus. And hopefully we'll get a chance to work with some of you in the audience, and you can get to experience that directly. So we want to move on to the next slide. So, that we talk about case study, this is sort of maybe some of the real detailed bits and bobs of my piece of this discussion today. We worked together on an Under Armour facility, a DC facility here in Baltimore. It was a 1.4 million square foot e-commerce warehouse. It was the largest building constructed in Maryland at the time of its construction. Had a mezzanine structure within it that housed some of their office components, as well as some of their MHE equipment. It was a brownfield redevelopment at a site called Trade Point Atlantic, which produced a whole element of its own challenges in getting out of the ground. Multiple levels of material handling equipment, full climate control, lead project, and it was design built, which is one of the, I think, key focuses that you will hear in today's presentation about what really helped drive success. And so while we were talking, if we want to move to the next slide, while we were talking about, sort of what elements could we focus on that kind of highlight a number of the touch points that we wanted to talk about, this idea of conveyance systems was really intriguing. It sort of was a little unique in the fact that there was as much hanging roof load conveyance in this building. And it produced a bunch of challenges. So, the challenge that ended up occurring was, how do we get a facility that needed to be constructed in a very short time frame to allow for a bunch of hanging conveyor loads that go within this facility and not cause a bunch of added time delay in having to retrofit the facility, and how do you accommodate a procurement process that Dave alluded to when, Sedlak and the team go through an evaluation period of how the conveyance system needs to work through vendor procurement. And, each one of these vendors and integrators end up coming up with a slightly different solution to the conveyance problems. And that poses a really significant challenge to the design and execution side of the business. And, one of the things that we took as an input from getting involved in the Under Armour job was, reviewing the facility that they had constructed in Tennessee and hearing how in that facility they went through a process of almost ignoring the hanging loads because they were undefined at the time the building was being constructed, and then retrofitting the structural steel inside the building once the shell was up to support these conveyor loads. And after hearing, a lot of the pain points that were suffered from what ended up being a much longer and more costly and impactful process of trying to do all this structural steel work above all this MHE equipment that is so sensitive, Under Armour and us and Sedlak came forward with this idea of sort of premeditatively trying to predict and provide some flexibility. And so that was translated to us in what we had to respond to in the form of our response to try and deliver the design. So if we go to the next slide, you'll start to see how this started fitting in. This is, Sedlak produced an initial set of plans through when you saw their earlier slides of their concept planning stage. They produced the concept plans of what the conveyance system might look like or will likely look like, knowing some of the inputs that the tenant was looking to have in terms of their capabilities of sortation, number of products, which products were going where, which were going to sit on the mezzanine, and so forth. And from that concept plan that's on the left, which is a little hard to see because it's a small slide and a lot of AutoCAD single lines on there. What we created, or what was created, was a whole host of improvements that were premeditatively added to the structural steel in the building in full bay widths. And those full bays were intended to be supportive of a hanging load, but not necessarily have to have the exactness in the exact location and the exact configuration, such that we could, through the course of Sedlak and Under Armour procuring their vendors that actually install the MHE, these things could slide around. And, this building is large, so each one of those little mini squares is a 50 by 50 or 55 by 50 foot bay. I mean, and that's a lot of movement in terms of, horizontal movement, one direction or the other, when you're talking about trying to run conveyance equipment. And so, this allowed us to build the building shell of this building while not having the final design, nor even having the final vendor selected. At the time that we started constructing the shell of this facility, Sedlak was not done through their procurement process, through their RFP process, getting integrators and vendors to respond to this. So that there was no, intimate knowledge of what that end conveyance system was going to look like. So if we go to the next slide, you start to see now where we are well into the construction of the actual shell build, when the final CAD files were able to be created for the actual MHE that went into that facility. And when you look at what the final bay design is on the right-hand side of this, you'll start to see that by and large, there may have been some changes that were ultimately needed to be made in some of those bays. But by and large, the premeditative thought process checked a huge box in enabling us to build the facility and not have to wait for all this to be done. And in fact, any of the modifications that we had to make, we were able to quickly make with little to no field modification in the building to accommodate this. And any of the field modification that we had to make was done at a time within the building that was being constructed where, there was the dirty process work being done. It did not have to wait until the building was complete and the MHE was being installed for this stuff to be installed, because you still had the full bays width in which to play with moving the stuff around. And I think that this worked out tremendously. This project was, from initial shovel in the ground to turnover was, I think, around 14 months. That included our design period for doing the design of these various the entire building. We broke up into sections. There's no chance that would have been done anywhere close to that same time frame if the traditional design bid build process was followed, or even if you waited for the MHE to be fully designed and procured before these were done. I mean, it was a huge undertaking, but I think it was a huge success by all eyes. So if we go to the next slide, some of these overarching lessons learned, and I'm hoping that, this is as a microcosm of how we would like to look at as a partner, any one of our facilities is, what creativity can we bring to the table that can understand what, where folks are in their process, what portion of the project is fully designable at today, and what portion of the project do we not have enough inputs in, and what maybe could we do in order to overcome those. So increasing the bay width allowed for the base building to be constructed during the selection of the conveyance equipment, right? Increasing the steel in the base building versus specifically location helped eliminate the rework in the field. And it's dirty. You have to repaint it. You have to touch it up. You have to be careful what you're working over. It's not stuff that we want to be doing inside a building that has MHE going in. It allowed, our overall communication with Sedlak and company allowed for all these ideas to be shared and all this coordination to be done, kind of up front, even if it was in the middle of the project. it was still upfront in terms of the overall critical path of the job to stay ahead. And I think that really, really helped. So if we move on, the second sort of topic is, sizing and what design considerations. I think this was kind of directly out of one of the comments and or questions that we had come in leading into this webinar. And so, we've kind of, pulled together a whole lot of information about, everything from real high level info to down into the specifics. And I've tried to kind of piece and part pieces because I think we have a pretty wide variety of folks listening in. But, we sort of break up our overall industrial distribution warehouse into three buckets, right? You have sort of a rear or front loaded cross dock. You have some type of a front loaded, a front or rear loaded warehouse facility, a cross dock distribution facility, and an e-commerce. And each one of those somewhat has a different use when you start looking at it, right? A cross dock facility has similar elements as a front loaded warehouse facility, but typically a front loaded warehouse facility, the product is generally staying in that warehouse a little bit longer than it is in a distribution facility. Generally, a distribution facility, that product in and out is a little bit faster paced. So, you start going into standard. When we talk a little bit in the future about racking, we have standard racking, typically what's seen in a front or rear loaded facility. You start getting into narrow aisle racking when you start getting into a distribution facility. And then an e-commerce fulfillment center tends to end up having elements of everything, right? But you add in the MHE component into an e-commerce traditionally that you don't have in the others. So you start adding conveyance equipment in, you start adding mezzanine structures in, and that really represents, what products are being shipped through the facility. I mean, again, it's all high level and broad stroke. Not everything I say is unilateral always, but generally in the e-commerce facility, you're talking about smaller products. You're talking about things that are going to go into a pick mod, into a bin to get pulled rather than sitting on a pallet, versus a distribution facility where you're either using robotics or manually operated forklifts. So when we start talking about, what some of the pros and cons are, and what Dave was alluding to in the beginning, ultimately the goal would be knowing what the business is and building a facility around it. But as we start broad stroking what we typically see, we start seeing generalities that start coming out where each one of these buildings ends up having portions of some of these facilities. So you start seeing down at the bottom of this slide where truck routing and circulation around the building becomes really important as these things change. I didn't have enough room on the slide, but on an e-commerce facility, parking for employees tends to be a huge component of it, and that tends to get added on, as well as remote trailer parking. But there's a lot to go into what the sizing and ultimate design looks like. If we go to the next slide, we've developed and helped sort of assemble sort of key elements and key attributes that really relate to what the most efficient building size is and what we see. And again, it might be a little hard to read, but there are absolute places in the country where some of this changes depending on what the trailer size is, right? I mean, 53 footers are pretty standard, but there are places in the country where those get longer and you are able to do it. So then the truck courts start changing size. Column spacing, we always look at what the column spacing is in the building, and there are absolute efficiencies. And when we're looking at a steel design of what those may look like, but if we're talking in the world of trying to really push towards an e-commerce facility like UA, some of these things really become the tail rather than the dog, right? The use in the building, the MHE equipment, that starts driving some of these decisions, and some of this other stuff starts, kind of sitting on the side. But if we are able to be at the table and have a discussion, what we like to also think about is generation 2 and generation 3 of this building. And that's where we start also then trying to drag the discussion back into some of these conventional, somewhat, call it standards or what we've typically seen, because, this tends to, capture a much broader audience of potential tenants. And so if we start building a building that's so specific to one particular group, one particular company, it starts becoming harder and harder to listen and hear what that generation 2 or generation 3 might be. And so that's where some of the elements that we've pulled together here, start becoming little background guidance for us when we start comparing and seeing where the discussion is leading us. We keep going. There's a lot obviously to unpack, but we talked on egress. Egress becomes a really big challenge and ultimately becomes the largest restraint on building width. Under Armour happens to be probably one of the widest buildings we've ever built. I think it was 670 feet wide. That posed really significant challenges in getting egress path to be able to work in getting people out of the building. For anybody who doesn't know, 400 feet tends to be sort of the magic standard. And so when you start getting close to that, you start to really get challenged because any horizontal movement left or right eats up the travel distance really quick. We're trying to get down the staircase from a mezzanine structure, which really was one of the biggest challenges on Under Armour, was the fact that there were mezzanine structures which also had to take into account the egress path. But that becomes a real big challenge when you start looking at conveyance equipment and all that. We have some pallet racking, sort of components in here, and some of the discussions that surround it. And we can have an entire webinar about, how pallet racking and the clear heights in the building affect the slab thickness and the slab design. Dave touched on a little bit, but one of the common themes of our industry over the past 5 to 10 years is the ever increasing height of the buildings, going taller and taller, and that's really a direct representation of folks trying to become more efficient as the FAR of these facilities continues to increase in dollars. Cubic volume becomes really important, but as the product height gets higher and higher, the tolerance for the floor becomes less and less, because as the forklift gets higher and higher, that error becomes greater and greater. And so you start running into, FMIN requirements and floor slabs, and that tends to get really expensive. And so, when we're able to get involved and kind of understand a little bit about the actual business that's driving the need for the warehouse, we can then start evaluating, various decisions as to, do we go higher? We pushback racking is not something that we see very commonly any longer, but, it's definitely something that, we would see in places that the product can sit a little bit longer than having to be in and out so fast. But, then you also have to weigh in on the pushback rack scenario, a lot more heavier loads implied on the floor, and so that may present its own set of challenges. To premeditate a little bit, the staging bay, is something that we've seen change so dramatically in the last 5 to 10 years. It is absolutely something that has been a huge focus in industrial buildings for a long time, but the use within that staging bay and all the things that end up getting crammed in there today compared to what it was one day, even 10 years ago, is crazy. I mean, this is where, folks are having shipping and receiving offices with oftentimes conveyance equipment going there at the same time that there needs to be forklift aisles and traffic lanes in and out for all of this. And so there just tends to be a whole lot of focus and attention to that, more so than just picking 60-foot initial column spacing in a clear height. And when we get an opportunity to get involved, we can start getting creative as to how that looks, and not, gone are the days of randomly selecting a door for a dumpster to be sitting at or a trash compactor. All that really needs to be thought through up front to really gain the most efficiency out of the use of the building. We move
Jeff,
forward.
Looks like
Yeah.
we've got a question
Sure.
from Jeff Fuller.
Hey, good afternoon. I appreciate your presentation. I wanted to bring up something or ask a question. one of the things that we've seen in buildings over the last 40, 50 years is a trend towards what's called investment quality real estate. And that ties in with your generation 2 and 3s of buildings. But basically, back in the 80s, we did a high-end data center that, I can't say it, but there were probably cruise missile parts being developed in it. It had vibration sensitivity much higher than anything else. But the only way they got financing on it was to be able to demonstrate that that building could work as a standard office building. So even though the building cost 4 or 5 times what an office building did at that stage, it went there. We had the same kind of things happening, some manufacturing facilities where the planning was for doing things in the future. And again, it was to be able to design something so that they could go out and get commercial lending and be lended as if it was a standard development rather than a specialty use. Do you find financing coming into making plays and being able to afford building in some of the upgrades, like you talked about increasing the live load of the roof structure to hang things or increasing the slabs on grade? But do you find that you get input from the financial side, or are you simply getting it from practical knowledge?
Yeah, I mean, I absolutely believe that institutional money has driven changes to the buildings that are being constructed today. There's no doubt. There is absolutely, some may argue exactly what the definition looks like and or individual elements, but there is definitely a definable Class A industrial building that has many similar or same comments in it that I think is essentially the driving force behind your question. And so I think the brokerage community, who is, their business, it revolves around successfully finding, the matchmaking, the marriage between, land seller and buyer and developer and end user and all the various folks involved. That they also tend to drive those similar sentiments because they also have, the deal doesn't work if the end user or the developer can't finance it. And so whether it's ultimately the financing or the brokerage community, they all tend to be sort of, harmoniously singing a similar song. And so, today's Class A industrial building is one that's a precast exterior or tilt wall building, concrete as opposed to a metal building. Now, the one caveat or asterisk to that, I would say, is in the cold storage market. IMP exterior skin is still the best way to build a cold storage building. But if you're talking traditional distribution, concrete exterior is absolutely, I would say, a prerequisite. There's probably standards that are going to vary depending on who you ask on clear height. But I would tell you, the taller the building that you can get, the better off and the longer in terms of generational you can get. I mean, anything over 500,000 square feet being constructed is generally 40-foot clear, pretty unilaterally. Are there places out there that are building 36-foot clear still? Sure. But I think, the 40-foot is really becoming the standard. And, they're pushing the limits. I mean, 40-foot clear for a distribution facility has largely been the cap for so long, based upon the clear height in the building driving the roof ridge line and the limitations of sprinklers. So a traditional ESFR sprinkler, which is one of the other things I would say is an absolute must-have for a investment grade facility. The ESFR system previously capped out at 45-foot ridge height. Now there are systems and heads that are pushing those limits today, and you can theoretically get upwards of 55 or 56 foot approved and still have an ESFR system. Although, there's a little bit of a debate between FM Global and NFPA on what some of those requirements are. So if FM Global becomes some of the hurdle if it's a institutional insurance type group, that might be a problem, but that the clear height is absolutely one of the characteristics that's there. Beyond that, I would tell you that there are common elements. I don't know that I'd be prepared to put my name down on whether or not, depending on the size facility, trailer storage is considered in that realm. But I will tell you that if there's an ability to build trailer storage on the facility, you better be premeditatively earmarking it, if not building it, because that, off-site trailer storage is becoming harder and harder to find, and trailer storage on site is becoming a greater and greater requirement for a lot of users. And then slab. I mean, slab is the other big element in our building that really is, probably one of the top five in terms of grading a facility and where it sits. And so, as you go higher in clear height, the slab thickness gets theoretically thicker. You have, greater weight. Anything 36 foot and below, 7-inch is kind of the absolute minimum of today in terms of a thickness. Obviously, there are designs and specific issues that pop up on certain sites that may dictate differently. But, if I'm broad stroking a building, a 7-inch slab is pretty much the minimum. 40-foot clear, 8-inch slab is pretty much the minimum. And then, depending on, folks' temperament for maintenance, depending on, whether or not, what the use is, are you having robotics in the facility? That's when we start talking about additive reinforcing, load baskets and things for crack control. And, if you're really building a bulletproof future, if I was being asked to build the most bulletproof building of the future, it would be as tall of a building as I could practically build with an ESFR system, with as thick of a slab as I could probably design that's pretty darn flat. I'm not sure that, just like I buy computers, I don't know that I'd buy the Taj Mahal, because I don't necessarily think most people need that. But I think that robotics are going to be a thing of the future. And so trying to get ahead of that curve on your slab flatness is really smart move. And taking advantage of cubic volume in these buildings is also really important.
Great. Jeff, thanks for your question.
Yeah, so if we move on, next slide. This is a little bit of sort of a recap slash, a little marketing, I guess, on design build. 70% of our overall volume comes from design build of some level. Now, some of these projects are design build from the start, where we're carrying structural and architectural engineering under our prowess. Some of it is mechanical and electrical and plumbing under our design build, and the ownership or the end users taking on architectural and structural. It's pretty uncommon for us to take civil design on. That kind of adds a risk element that is non-traditional in this development market, this type of contracting. But what it allows us to do is become involved in the project at a very early stage that allows us to ultimately help in delivering the product, not only much faster, but we find that it reduces the cost overall significantly, and it shifts the risk to our side of the table. And I think we're much more accommodating at understanding that risk. I don't know that we're here to be anybody's insurance policy, but I think the fact that we have an institutional knowledge at how to execute these facilities, we have ways in which we can help mitigate some of those risks in subcontracting our work out and managing through specifications and things that doesn't necessarily happen when we're just trying to follow a set of plans that somebody else has provided us. And so, some of the graphics here is just, sort of high level representation of the fact that, we can get moving really fast. And, I talked about the Under Armour project. I mean, to execute that size and complexity of a building in 14 months, Honestly, it was unheard of, even in a design build world. But, we've sort of tried to do some backwards math there. And I think you would have easily added 8, if not 12 months to that project if you took a more traditional route of just trying to design all these elements and then get pricing in order to execute us on our side. And I don't think that's an exaggeration at all. I mean, I just add up the time that we spent involved in actually designing the building while our execution team was building it, and you can quickly and easily get to those numbers. We move on. I think the other thing that everybody gets kind of before we move on quickly, one thing I just remembered is, we do the vast majority of our work open book. And I think that's the other thing that people miss when we start talking about design build is the fact that, we are not here to obscure or hide behind any pricing. We're not here to try and, hide really anything. We want to be looked at as a consultant that is assisting in the execution of design more than a contractor who's hired and, given a contract for a certain amount of dollar and go away. And so we do a significant amount of our work open book. Everybody gets to sit at the table when we're selecting our subs, when we're figuring out what their scopes need to be. And, there's a lot of information share that happens where people don't realize when we're hiring an electrician, oh, hang on a second, I need to add this in. And the time to add that doohickey in is at the time where we're hiring that electrical sub, not at the time where we get to the end of the job and we forgot we needed it because, it's going to cost more. And so having that sort of, process become a little bit of a checklist where people can, be premeditatively thinking about some of those elements and forced to think about it earlier than they would normally. I think it gets a lot of those things off the table earlier in the process. So moving on, sort of the final overarching topic that seems to come up and was definitely heard in some of your comments that was sent in, it was tariffs. And what I would say on this subject from our perspective is it's the big world of the unknown. It's changing on an everyday basis, and it's really hard to predict. And it at times feels like we're right back in the world of COVID. But with all that uncertainty, with all the unknown, with all of the thought of having the ability to unpredict, what I would tell you so far is what we're seeing is that so far in our facilities, the impact of tariffs has been somewhat negligible. So far, the cost impact is something that is, I think, being negated in some part and in some level due to some slowing of the overall industry on the distribution warehousing side. And I also think that there is a lot of creativity that these suppliers are starting to utilize in an effort to maintain their competitiveness, even if they are having to absorb some dollars or it's costing them some dollars in tariffs. So far, there's some interesting ways that we've heard folks importing products to different countries before they get imported to the U.S. to reduce tariff amounts, modifying, the way that they're procuring some products, changing some of their sources of chemicals, changing some of the composition of the chemicals going into the products. There's a lot of products that are actually made in the United States, despite the headlines you hear. But the tariff starts coming into the raw materials that need to get imported to the U.S. in order for them to produce. And we're seeing, some of that and hearing how some of these guys are changing it. So to date, in the first 5.5 months of this year, I don't know that we've actually seen any, what I would call substantial. Have we seen some dollars and cents here a year? Yes. But, when we were looking at COVID, where the costs of our facilities over the course of COVID increased by 45%. We're not seeing anywhere near that. What do we expect to see? Well, it's really hard to say for sure overall, but I would say the things that we're keeping a very close eye on are electrical supplies, switchgear, lighting. All of those things are things that never fully recovered from COVID. All of those things, the supply chain still seem to be somewhat broken. And if you start looking at where a lot of these components are manufactured, it's either Mexico or China. And so while we still haven't seen a huge impact today, we believe, or at least are keeping an eye very closely on those. The second is going to be in finishes. By and large, the large scale of our industrial facilities don't tend to have a ton of finishes in them, paint and carpet, ceiling tiles, a lot of, aluminum storefront materials, all of that. A lot of our buildings don't have a ton of it, but, to whatever degree there's going to be an office build out of some type, we believe that there's going to end up being some substantial increases in that. I mean, there's not many manufacturers of flooring, for instance, in the United States right now. All of that is being imported, or the lion's share of it. And that the stuff that's not being imported is significantly more expensive. So we believe that, there's likely going to be some effects there. And then specialty equipment, that's the wild card, right? We think that there's likely going to be some uptick in costs for specialty equipment. But that's a really difficult thing to put our finger on, because we don't buy it necessarily every day. We buy a lot of joist and deck. We buy a lot of concrete. We buy a lot of, certain things. What we don't buy a lot of is, specialty one-off items that, may be on one every 10 projects. And so that is some of the things that we are, a little cautious about. Well, those are our three topics that I think we were intended to hit, Dave. So I don't know if we have any questions.
Yep. Thanks, Jeff. Good segue. So we do have a few here that came in that we've got here in the deck. First one's, what are the latest trends in distribution design?
Yeah, I mean, I think, Jeff's question maybe led us down that a little bit. I would say that, in some ways we're in an ever-changing world. One of the pieces that sort of relates down to the question number 3, so maybe I'll answer two questions in one, is there is absolutely trends that are pushing us to be more green in our facilities. And some of that is based directly off of local and regional changes in legislature. What used to be somewhat of a nice to have and or only the most long-looking, future-looking folks were thinking ahead when they're building a building as solar. A lot of locations now across the United States are mandating that the roof structure be solar ready. There are a growing number of jurisdictions and states that are asking for some level of EV charging to be added in. Some states are mandating EV charging as a prerequisite. Some states are having it be sort of EV ready, which involves, various conduits and other things depending on how that code gets interpreted. But the green revolution, the electrification is definitely something that is heading. And then, to that sort of solar and electrical, the other thing that's getting there is creativity on electrical distribution. Utility companies are running out of power, and the data center side of our industry is sucking it up as fast as they can create it. And so we're seeing a lot of facilities that people are having to get creative on how they're overcoming their utility consumption. Gas generation on site is surprisingly more common today than it's ever been. Multiple projects we're looking at right now that include a gas generation facility on site, which wasn't even part of a dialogue a couple years ago.
Okay, next one. How are construction contracts being structured to deal with potential tariffs?
Yeah. Difficult to necessarily say exactly, but some of the most successful structures that we are executing today involve a contingency budget that is held on the ownership side but recognized within our contract, a time frame in which us as a contractor has to design and procure through subcontract the elements, a recognition by ownership that we are able to modify and utilize the contingency for cost increases through the course of that completion of design and procurement period. And then beyond that, a commitment from our side that we will honor the final cost unless there is some super extraneous situation that occurred. So, if the tariffs that were in place during the execution remained and were unchanged post our buyout period with subs and the ability to use a contingency during that buyout, we would honor the cost beyond that. That seems to be the structure that is most acceptable by both sides and gives the ownership group the sort of longer term commitment that they need to garner funding, because that funding source tends to be the one that objects to open-ended cost structures the most.
Yep. Okay. Any pricing guidelines for new or expansion projects?
I'm going to say that anyone who's on the call who's looking for some pricing guidelines should really reach out to us and allow for us to help. It is such a broad question that has so many variables to it. But what I will tell you is we have probably 20 to 30 guys in our pre-construction group across the country that chew through anything from concept budgets, pencil sketches on paper, performance specifications for buildings that want to be used for an idea of a building that's not even built, that I would much prefer, rather than put down a dollars per square foot in a presentation, I would much prefer to offer up a free of charge comprehensive help in helping you figure out what that pricing needs to be for your project, even if we don't end up building it.
Fair enough. And then what are some of the unexpected situations you've encountered during site preparation?
Yeah, somebody knew that we did this building at Trade Point Atlantic. I mean, I would say that this is an easy lob pitch to remind and or inform everyone that our company has a very long and tenured history of building on brownfield sites, which tends to be the lion's share of where these buildings go these days because the good greenfields are gone. And it still amazes me to this day of all the various things that we end up having to deal with in contemplating and executing these jobs. The Under Armour job on Trade Point was probably one of the most challenging sites in my career. An ex Bethlehem steel mill that had been demolished specifically for this redevelopment, but the amount of underground basements, tunnels, shafts, and things that needed to be uncovered and dealt with, to the issues with slabs and existing structures that couldn't be removed, to the environmental contamination that existed on site, and all of the various things that we needed to deal with there, really presented a hallmark project from dealing with the unexpected situations. But taking off of that and looking at, other things. I mean, every day we deal with something. It seems like, to my point here, or whether if it's not a brownfield site, it's a site that's been passed by generations of people, because the site is, got a lot of wetlands that needs to be dealt with, which just, it kills your production and moving dirt because of how moist the soil is and how much challenge it is. We've built on top of landfills. We just finished one in Delaware shortly, where literally we're having to dig through the trash heap in order to get support structures in place to support the building, so it didn't settle as the trash heap slowly decomposes. So there's a lot of situations that we run into, but that's the thing we excel the best at. We like those projects. I would much prefer a very difficult project that required us to put our thinking cap on, because I think that's where we excel our best. I think that's where we do our best work. I think that's where our team gets the most enjoyment and excitement out of doing their day job. And I think it's the thing that all of our employees walk away with the most and greatest sense of satisfaction.
All right. Well, that wraps up the questions that came in. I guess we still have a few more minutes left. Do we can open it up for another question or two if anybody has one? All right. See any hands raised? Dave Teeple.
I've got a question if you can hear me.
Yep, we got you.
This is Ashton Williamson with Colliers in Norfolk. I heard it said on the call a few minutes back that the designer would go as high as he could with the floor as thick as he possibly could within reason. I'd like to ask, what would that be today for a 40-foot or a 45-foot building? How would you design the floor for adequate point loads, for heavy loads on racking?
Yeah, I mean, I would say an 8-inch unreinforced slab is by far the most common. We do not see very often the current racking designs with the ability for the foot configurations that we run into significant challenges with an 8-inch unreinforced slab on a 40-foot clear building. There is probably more than 50% or more of the developers executing those type of facilities are putting in some type of reinforcing in the load bay, whether that's dowel baskets or some other type of reinforcing. We do not see, if I was to broad stroke the answer, we do not see reinforcing in the whole of the slab very often. Generally, reinforcing of the entire slab is either a result of a poor soil condition or a result of a concentrated heavy load that is often coming from floor loading more than it is racking. We don't often see racking loads because, racking, we have the ability to spread those loads over the feet of the racking that end up going over a large area. We oftentimes see slab designs being most challenged when we have a floor loaded tenant, like a floors and decor, or somebody that's trying to store pallets of ceramic tiles or hardwood flooring or things like that. Those are the users that tend to challenge a floor slab support more than a fully racked building. But I would say for a 40-foot clear, 8-inch unreinforced is absolutely what you should go for as a bare minimum. We would say that, we would probably recommend some level of reinforcing in the load bay, some dowel baskets or something to help with some crack control in that area, given the heavy forklift traffic of the load bay. And then reinforcing the rest only on a case-by-case basis.
That's helpful. Thank you.
Thanks for the question. Any other questions?
Yeah, one other question, Dave. So in recent years with buildings, both with the building cost and the material handling cost has been a real challenge for the industry because of the volatility of the steel market. Where do you see it currently, and how much is that affecting what you do?
Sure. I'll cover the building side, Dave, if you want to inject on material handling side. On the building side, I will broad stroke sort of, again, and not to be particular and just give everyone a sense, you know, in 2016 or all the way up, really honestly through 2019 at the beginning of COVID, a 500 to million square foot building, you could average across the United States be pretty confident that your steel package, your structural steel package, was going to cost somewhere between $5 and $6 a square foot. That was kind of like the pocket math that you could, sit at a dinner with somebody and run the numbers and be right the majority of the time. That $5 to $6 number ended up being probably a $15, $18 number at the height of COVID. And so you can imagine, I mean, steel being probably, call it 30% of the cost of these buildings. That large of an impact, 300% increase in price, had a dramatic cost increase on these buildings. That same steel package today is probably down to $10 a square foot, thereabouts. So it is not fully recovered back to the pre-pandemic days. We don't expect it to recover back to pre-pandemic days, but it has come back down to be within, 15%, 20% of what it was pre-COVID. And so, there are always, cases and situations that will challenge those numbers. But, if I'm to broad stroke things, that's kind of, that's where we're seeing things today. And we don't anticipate a significant challenge as we move forward. There will be cases, we have seen some notifications this year about certain rolled products going up slightly in price and tube steel going up. But when you really look at what the overall makeup of the actual steel package is, it kind of becomes rounding errors. You're starting to talk about 25 cents a square foot as kind of a max, problem, as compared to what was in the past where you were talking about, $10 a square foot as being the max problem.
Yeah, from a material handling perspective and rack and the like, yeah, we saw those same significant spikes heading into COVID with not quite returning back to pre-COVID levels as we stand today. So,
yeah, I would say if you have a project that you had a budget that didn't work from, say, 12 months ago and prior, we would love the opportunity to look at that again, because I would bet that you'd be surprised your overall number is probably down, 25, 30%.
Yep. All right, one last question. All right. Well, first off, Jeff, thank you for your participation here today and the partnership, and appreciate all the information you shared here. Also, everybody, thank you for the attending the virtual event. We've got a few more coming up here. Swisslog on June 11th, Easy Metrics on September 9th, and then Barrett Distribution on October 7th. So look out for those coming your way via email. And that'll wrap up our session. Again, thanks everybody for attending. Jeff, thanks again. Talk soon.
Take care.
Bye-bye.
Thank you.
Thank you.